Good afternoon, everyone. My name is JC Rippiger, and I'm here. I'm the marketing coordinator here at ISAC. I'd like to thank you all for joining us today, and we are happy to welcome Summit Carbon Solutions. They are a member of the ISAC Preferred Vendor Program at the elite level, so we greatly appreciate their sponsorship and support. Before we begin, I'll mention that this webinar is being recorded and will be available to view on the ISAC website after we're finished today. If you have any questions for them during this presentation, please leave those in the Q&A box at the bottom of the screen, and they will leave time to answer those at the end. Now I will go ahead and pass it off to Summit Carbon Solutions so they can introduce themselves.
Hi, good afternoon, everyone. Thank you so much for joining us today. We know many familiar faces are in the crowd, if you will, so we really appreciate you and your willingness to spend your lunch hour with us on this Wednesday. My name is Sabrina Ziener. I'm the Director of Community Relations for Summit Carbon Solutions. So our goal today is to help you, our county officials, to understand the benefits of our project. To do this, we're going to walk through a couple different things. We'll start with the economic impact of our project, specifically the tax benefits that your county will see, and then we'll help to alleviate some of the concerns while highlighting the safety of this transportation line. So I'd like to quickly run through the faces that you'll see here on this meeting today. They are experts in their fields, and I'm very thankful that they are willing to take time out of their busy day to do this webinar with us. So you'll see Kylie Lang. She is our Iowa project manager. Joel Gustafson is our VP of tax. And we have John Godfrey, who's a senior principal consultant with Integrity, I don't want to get it wrong, Integrity Solutions Group of DNV USA. So I'm going to share my screen here. We have a presentation that we would like to give you all. And then if you have any questions, as JC mentioned, please just feel free to put those in the chat, and then we'll address all those at the end of our conversation. So Kylie, we'll start with you if you don't mind. If you could just give us an overview of the project, please.
Yeah, I'm going to be brief with the assumption that most people on the call have a basic understanding of the project. But what the goal is for the project is to collect carbon dioxide currently being emitted at the ethanol plants across the 5-state footprint that you see on the screen, capture it, compress it, move it via pipeline up to North Dakota, where it will be permanently sequestered underground. The reason behind this is the carbon intensity score, which is determined at the government level for an ethanol plant. Reducing the carbon intensity score by capturing the carbon allows them to sell into and compete in the low carbon fuel markets and industries. So that's the goal of the project. We've had 33 plants sign on to our project, 32 of them being ethanol plants. And you can see, if you look at the blue dots connected to the blue line, the blue dots show the ethanol plants that we are connected to. The blue line shows the pipeline that will move the product, the CO2 from the ethanol plants up to North Dakota. On this map is also showing us where sequestration zones are, which is basically the correct geology that allows you to sequester the sequester the CO2. So the CO2 will be sequestered ranging from 1 mile to 2 miles deep underground, and it's for permanent storage. So once it goes in underground in North Dakota, it will permanently remain there. So the pore space capacity in North Dakota actually has about 250 billion tons. Right now, on average, we have about 10 million tons per year signed up to our project. So in terms of pore space capability, there's no time frame that we're going to run out of space in North Dakota or even line of sight to fill the amount of pore space that's available in the state. Our pipeline I mentioned is 10 million tons. We have at this point, it has the capacity to go up to about 18 million tons, which will allow us, you can see the white dots on the screen, show ethanol plants not currently signed up with our project, although several of them are signed up with others. There's 2 pipelines that are going to Illinois where they'll sequester, and there's 1 pipeline going to Wyoming where they'll also sequester. But the growth for the industry and the opportunity for ethanol to move into the low carbon fuel market, both for which states that are requiring low carbon fuel at this point, which is also a growing number of states in parts of Canada. It also, into the future and future government regulations to decarbonize will allow them to have a seat at the table in the new energy and low carbon fuel energy conversation.
Kylie, thank you very much. And I know that's a lot to digest if you aren't super familiar with our project. So again, please feel free to put any questions in that Q&A box and we'd be happy to answer them at the end. Now I would like to bring in Joel Gustafson, who is our VP of Tax. Joel, thanks for being here. I know you have worked a lot with counties kind of on an individual basis. So if you wouldn't mind giving us a quick bio and then just answering some of the questions that have been the most common that you've heard.
Yeah, no problem. Hi, everybody. As Sabrina mentioned, Joel Gustafson, Vice President of Tax at Summit Carbon. I joined the company in September of last year, so approximately 6-7 months here. Prior to Summit, I'm a graduate of Minnesota State University and started my career auditing grain elevators in that area. I got my master's in taxation from the University of Denver. After that, I spent 6 years in public accounting and then joined a large midstream oil and gas company for 9 years as their VP of Tax. And, you know, I mentioned the midstream oil and gas company because we did have centrally assessed assets, not in Iowa, but I think I can provide some insight on how I expect Iowa to value this pipeline. So in my 7 months here, as you can probably imagine, I've been asked various property tax questions by local assessors, county commissioners, you know, et cetera. You know, for this webinar, I'll just go through a few of those. And if I don't cover anything through this little Q&A, please follow up with me. So the first question I always get is, how will the pipeline be valued, right? So we expect the pipeline to be centrally assessed by the Iowa Department of Revenue. And for those of you not familiar with centrally assessed property, Summit reports a number of items to the DOR, including, you know, the main ones would be miles of pipe, cost, and financial information. The state then sets a value using various methods, and the three main ones are a cost approach, an income approach, or a debt approach. And then once they have the value, it gets sent down to the counties, and the counties apply their tax rates, you know, mail out property tax statements, collect the revenue, and distribute the funds. Now, I always point out that the cost for centrally assessed property is not normally what you would see for business assets. They bring in all property. So like normally when you value property tax, you know, you're looking at tangible items. Well, the state for centrally assessed brings in intangible items. So they also bring in items like right-of-way, crop damage payments. We're making pretty much anything that gets capitalized to the project. So usually I've always seen that the property tax base is higher than what you would see at a local level. So that's usually the first question: how will the pipeline be valued? Next question, like if a county has a capture facility, and as Kylie mentioned, these are connected to the ethanol plants, I'd expect these to be locally assessed. So similar how how your assessors would tax other property in your county. And then the next, probably the most important question is, I think on the previous slide, there were some property tax estimates. And we always get asked, how were these calculated and by who? You know, because they are material numbers and obviously important to each county. So what we did early in the project is we engaged the national public accounting firm Ernst & Young to perform what we call an economic impact analysis. And if you're not familiar with this, it is published to our website. But this is where the estimates are coming from. And in that analysis, I mean, there's a number of items: job creation, you know, how many capital expenditures, you know, how much we're going to spend in each county, and then the property tax estimate. Well, for the property tax estimate, the best information we had at the time was cost. So the way I think of it, and at a high level, let's just say the cost in Iowa was $1 billion. A county has 10% of the miles of pipe, well, they would get 100 million valuation. Now, if their property tax was 2%, that's how they get the 2% estimate. So I have had some counties look at that economic impact analysis and they take their property tax and divide it by the capital expenditures, and they call me and say, hey, I think your rate seems high. Well, the capital expenditures in there, as I mentioned previously, it does not include the intangible items like right-of-way, crop damages, it's strictly focused on the tangible items, and it's a little confusing how Ernst & Young laid that out. But it has something to do with the capital expenditures is only new asset development and is not reflective of the property tax base. So the property tax base will be higher than that capital expenditure column. You know, people have asked, will the asset depreciate over time? And yes, I mean, it's going to depreciate. However, that's one of the reasons the state has multiple valuation techniques. So at my previous company, you know, we had a 555-mile pipeline that went from Colorado, the DJ Basin in Colorado, down to Cushing, Oklahoma. And what I saw those states do is they started with a cost approach. So there would be 100% cost valuation the first couple of years. And then as the assets started producing revenue, and usually the first year might be light because things are coming online, then they would switch to like a 50% cost and 50% income approach. So as long as the income is, you know, increasing each year, I would not expect the depreciation to affect the value materially. And then also in the scenario where it would affect it, you know, they would follow our financial statement depreciation rates. And I was talking to our controller before this call, and I think right now he thinks it's going to be a 40-year depreciation. So that would be 2.5% decline rate. So it's going to be a slow burn on the depreciation. You know, similar lines to the depreciation, I always get asked how many years the pipeline will generate property tax revenue, and it will generate for the life of the pipeline. I've even seen where decommissioned pipelines still have a fair market value. So, I mean, I really think until this thing, you know, comes out of the ground someday and gets decommissioned, that it will generate property tax for many, many years. You know, the next question I probably get is what items could increase or decrease the property tax estimate? And I mean, I'm sure you have the same list that I probably came up with, but obviously cost. You know, unfortunate for us, the cost is increasing with inflation, so that'll play into it. On the income approach, right? Our income's based on the volumes produced from ethanol plants. Well, that's, you know, dependent on corn production. So I mean, you know, that could go up or down depending on the year. Customer volume, maybe we bring on a customer, maybe we lose a customer at some point. And then the other item would just be the exact rate for the county. So right now, the rates we have applied are kind of an average. We have not gone township by township, hospital district for school district, and did the exact rate. So there might be a little delta in the rate that's used. I did get a question from one county that said our local assessor does not have experience in valuing capture facilities, and will Summit assist in the valuation? So in my career, the way I've done property tax is I usually engage a property tax firm to help set the values the first couple of years. And the firm I've utilized in the past that I expect to utilize for this project is K.E. Andrews. And I do that for a number of reasons, but you know, they usually have comparable customers and they have contacts in the state. So that's how I envision assessing the capture facilities in the first couple of years. So yes, Summit will assist the counties via probably a third-party firm. And then lastly, and Sabrina, if you could just go to the next slide for a second. And lastly, you know, I get asked where local jurisdictions can find more information. So I pulled, you know, these are the two main code sections, but all based on chapter 438 from Iowa's code. And the first 438.1, I mean, that's where we believe we will fall into this definition for being centrally assessed. And then 438.113 kind of goes into and explains, I underline the sentence there, but the taxable value shall include the right-of-way, easements, pipeline station grounds, so pretty much all the costs. And then the last sentence highlighted, you know, just kind of shows the Iowa Department of Revenue's flexibility to assign a value to the county or to the asset, I mean. So, you know, if you're looking for more information, a straight Google search of Chapter 438 Iowa Code should pull this up. I also encourage you to call the Iowa Department of Revenue and ask them any questions. And then lastly, I have spoke at county commissioner meetings. I've taken phone calls with local assessors, and I'm always happy to do that. So if there's any question that I went over there probably pretty quickly that you want to follow up on, or maybe, this is obviously directed at all the counties we're in. If you have a question specific to your county, happy to go into in more detail. But that's what I have for today. Thank you.
Joel, thank you so much. And we haven't gotten any tax specific questions yet, but if we do, Joel said that he'll be able to stay on until the end to that question and answer portion, so he can answer any questions that come up through the chat as well. Okay, next we are going to address some safety issues with the carbon capture pipeline. So I would like to introduce to you John Godfrey. So Mr. Godfrey is a senior principal consultant with the Integrity Solutions Group of DNV USA in Columbus, Ohio. Mr. Godfrey has more than 35 years of experience in the pipeline industry. So prior to joining DNV, he held various positions in pipeline operations, manufacturing, consulting, and asset integrity services. His experience includes integrity management program development and management, regulatory compliance, standards development, pipeline operations, pipeline design and construction, line pipe manufacturing, and non-destructive examination. Mr. Godfrey is the past chairman of the API Pipeline Integrity Committee, past vice chair of the PRCI Materials Committee, and previous member of the API Operations Technical Committee. So thank you, John, for joining us today. You are the expert in this area, and we are very appreciative of you taking your time with us this lunch hour.
Thank you very much. And I apologize, Miss Sabrina. When you asked me to send you a short bio, I didn't realize it would read so long.
It was not too long.
That was a mouthful, and probably more than I deserved. And I can't take credit for being a pipeline safety and CO2 pipeline safety expert by myself. DNV is an international organization that provides risk assessment, engineering, and consulting services for a variety of industries, including clean power generation, oil and gas, maritime, even medical field, and business assurance. We're located in over 100 countries worldwide, headquartered out of Norway. And there are about 15,000 of my colleagues across the globe, and I avail myself of their expertise at every possible opportunity. So a little bit of background about carbon dioxide pipelines in North America and the US specifically. There are currently over 5,000 miles of CO2 pipelines in operation in the US. Almost all of them are located in the oil and gas producing regions of West Texas and Oklahoma and the Intermountain West and the Gulf Coast, and are engaged in enhanced oil recovery. There's also quite a bit of CO2 usage, of course, in the beverage and food industry and other industries, but not a lot of that is transported via pipeline. CO2 pipelines are regulated. They're regulated by the Department of Transportation, the Pipeline and Hazardous Materials Safety Administration, under the Pipeline Safety Act of 1979. And they're regulated as hazardous liquid pipelines. And I'll get into more of that later. As far as the CO2 pipeline systems go, the largest diameter CO2 line in current operations is 30 inches in diameter. And some of the systems operate at pressures greater than 3,000 pounds PSI gauge. CO2 is considered a non-combustible, non-flammable product, although it's regulated to the same standards as refined petroleum products such as gasoline and diesel. Also highly volatile liquids, propane, ethane, butane, and also highly toxic liquids such as anhydrous ammonia. And it's regulated to the exact same standards. The US has the greatest experience and the greatest regulatory framework for CO2 pipelines worldwide. We have had over 40 years of operational experience with CO2 lines. That's greater than any other region of the world. And the U.S. Pipeline Regulatory Code incorporates CO2 pipelines, which is unique. CO2 pipelines are just getting started in Europe and Asia and other places around the world, and the regulatory framework is not nearly as developed. So if you could change slides, Ms. Sabrina. A little more about the Pipeline and Hazardous Materials Safety Administration and how CO2 pipelines are regulated. The hazardous liquid pipeline regulations basically cover pipelines from cradle to grave. Design requirements are specified in the regulations, and where appropriate, industry standards such as American Society of Mechanical Engineers, the National Association of Corrosion Engineers, NACE, which is now called AMP for some reason I'm not sure of, as well as the American Petroleum Institute. A lot of those standards are incorporated by reference. So PHMSA avails itself of the best information and technology they have available for pipeline construction and pipeline design. This includes a maximum pressure requirement of no more than 72% of the yield strength of the material, which in the case of these pipelines and all hazardous liquid lines is steel, carbon steel. And also requirements around the placement of valves, the control of pumping equipment, the control room and how alarms are managed. All of those things are incorporated into regulation. As it applies to CO2 pipelines, some of the most important parts are the integrity management program provisions, where pipelines are required to periodically assess and evaluate the condition of the pipeline and make repairs to any anomalous findings that may be indicative of defects in the pipe wall, such as internal or external corrosion or mechanical damage from a third-party line strike. There are a couple of specific items to CO2 pipelines in the integrity management regulations. One of those is that the pipeline be evaluated and precautions taken for something called fracture control, specifically a ductile fracture. And that's a fancy way of saying that at the temperatures and the pressures that CO2 is transported, if the pipeline cracks, if it fails by fracture, the fracture can actually outrun the decompression wave in the CO2. So the speed of sound in steel is faster than the speed of sound in CO2, and the crack will continue to grow, aided by the pressure in the CO2, until it reaches a stronger material that arrests that crack. The regulations require that be evaluated for all CO2 pipelines, both existing and new, and that crack arresters or appropriate materials be selected to mitigate that threat. The second requirement, which we'll discuss a little bit more, is around air dispersion modeling and evaluation of the risks and the potential consequences of siting CO2 pipelines. Want to mention a couple others briefly. There is a control room management provision in PHMSA regulations that specifies the training and the types of controls and the responses that are required by the control room that operates the pipeline. Controllers, as well as all people who actually participate in the operation of the pipeline or touch the pipeline during maintenance, are required to be qualified under US DOT regulations. The qualification program is established by the operator, but it is a series of tests and demonstrations against established procedures to prove that the operators have the requisite skill and knowledge to operate the pipeline, to respond to maintenance issues, and most importantly, to respond to abnormal operations and emergency operating conditions. Which brings us to the final point of the PHMSA regulations, which is the requirement for emergency response planning. All hazardous liquid pipelines are required to document their emergency response plans, and they are subject to review by PHMSA. And PHMSA will periodically inspect and audit those plans as well. And of course, they're thoroughly reviewed following any incident. So it's something that is incumbent upon every pipeline operator to not only implement but to maintain and to update throughout the life and operation of the pipeline. Next slide, ma'am. So that kind of brings us to an issue or an incident that occurred a few years ago in Satartia, Mississippi. And this is probably the most publicized CO2 pipeline incident in the United States. And what happened was a Denbury pipeline carrying naturally occurring CO2 to an enhanced oil recovery operation suffered a catastrophic failure. Abnormal weather events, a lot of rain, a lot of erosion, caused an area adjacent to a highway to subside. The pipe was fully exposed, and the strain on the pipe produced a rupture at the weakest point in the pipeline, which was actually right at the vicinity of a girth weld. Nothing was wrong with the girth weld. There was no indication that the girth weld was substandard. There was no indication that there was an undetected defect in the girth weld. It was simply that the pipe was stronger on either side, and that it just found the weakest point in the string of pipe, and it pulled apart at that location. This released a CO2 cloud into the area that traveled through a lowland, a creek bottom area in the vicinity or towards the direction of Satartia. A number of people were evacuated from the community, and a number of people sought medical care at their doctors and at the local hospital. Interestingly, none of the medical care actually rose to the level of a DOT reportable injury. And there were gratefully no fatalities of people, livestock, wildlife, or anything else at the site. The leak was compounded by the fact that it was naturally occurring CO2. And it had a certain amount of hydrogen sulfide in the CO2 with it. The people on site described seeing a greenish cloud and smelling the smell of rotten eggs, which is very characteristic of H2S. And although it's not known, it's surmised that a number of people who sought medical care were really dealing with symptoms of H2S exposure as compared to CO2 exposure. But there were documented cases of exposure to CO2, but gratefully those people bounced back and didn't require any overnight hospitalization or admittance to the hospital, which is the measurement that DOT records. One thing that DOT did note in their incident investigation was that Denbury Resources had done a poor job of evaluating the potential impact of a release, that their air dispersion model did not indicate that Satartia as a specific community could be impacted. So their emergency response plans were deficient in terms of notification to emergency responders and getting folks on scene early enough to help with the evacuation and help people who were coming up with symptoms of CO2 exposure. So next slide, ma'am. So what is dispersion modeling? Well, dispersion modeling is basically a couple of different ways to do it. Empirical and computer-based models can estimate the direction and the concentration of CO2 dispersion, or you can go all the way to computational fluid dynamics and actually model what would happen from a very specific release event. And that's mostly common for plants and large fixed facilities. For large linear facilities, the first case is more common, where computer programs are combined with local site data to produce estimates of potential dispersion in the environment. A dispersion model will take into account the environmental conditions on site, most specifically temperature, wind direction, humidity. There is an atmospheric intensity factor, how much shear is in the air and what the typical weather conditions might be, or even adverse weather conditions for a location. So it's all stuff that's very site or location specific. Can also be generalized, for a particular county or for a particular area. What are your average and your min and peak temperatures? What's your average wind speed, peak and low wind speed? Where does it go? Release rate also factors into dispersion modeling, although not as much as you might think. The release rate and total volume out will influence the amount of time somebody is exposed to CO2. But the distance from the source, the actual dispersion, is more dependent on the environmental conditions than it is the total volume. So the volume of the release, once it reaches that dispersion distance, the total volume really doesn't matter as much. Now, elevation is listed here on Summit's slide as a factor, and I would caveat that and say not so much elevation of the pipeline as the ground effects. You know, are there low spots? What CO2 is about 1.5 times heavier than air. Once it's released, it will follow ground contours. It has the ability and propensity to follow, you know, creeks and low-lying areas, but as it does, it continues to disperse based on the environmental conditions. But that is something that also is layered in as part of the model. So one more slide, and I think this is my last one. Y'all won't have to suffer with me much longer. CO2, as I mentioned before, is not combustible and it's not flammable. In the I'm stammering here. Global harmonized system of hazards, much like the old MSDS sheets, it's not even identified as toxic or acutely toxic. All right, it's really best qualified as a mildly toxic sort of substance. Okay, it is characterized as an asphyxiant, meaning it can displace oxygen, but even without displacing oxygen, it has the ability to stimulate or depress the central nervous system. And immediately after exposure to high levels of CO2, you know, breathing rates will change. You know, partial air pressure or CO2 pressure in the lungs will change. There's acidity impact on blood concentration. People start to get effects of it. And at concentrations in the 17 to 30% volume by air, or volume in air, 17 to 30% volume in air of CO2, you know, it can cause severe health effects leading up to convulsions and coma and potentially even death in a short period of time. To help understand how those effects or how those concentration are reached in the event of a release, DNV has conducted a number of large-scale experiments, full-scale, using actual pipe that's actually buried on site, and it is ruptured and a release is allowed to occur. And it is instrumented so that the concentration levels at various distances can be observed from the pipeline release. And this is one graph from one full-scale experiment. It's not meant to be totally conclusive, it's representative. But considering that, you know, threshold of 17% by volume is the action level, and 10 to 15% by volume can cause dizziness or drowsiness, unconsciousness if exposed for several minutes. Even in this case, at the closest locations around 50 meters, those thresholds were not reached, and it quickly, you know, dropped down the further you got away from the release site. Now, interestingly, and for full disclosure, this test only lasted for around 200 seconds. So you can see that when the test ended, the concentrations began to immediately drop, except for that concentration out at 500 meters. You notice that the concentration of CO2 from the release didn't get to that point until about 400 seconds, 500 seconds past the onset of the release. And at that point, a concentration so low as to not be considered a health concern. So there is more and more data that's being added so that we can refine air dispersion modeling. The Department of Energy in the US just last month sponsored a workshop, and they've allocated funds to do specific research on CO2 to help us expand on this. But the bottom line message is that CO2, while being hazardous and treated like a hazardous liquid, presents a unique risk, and a unique risk that's best managed through prevention. And that's how the pipeline industry at large is taking risk management, is to prevent any potential release and then provide the emergency response capability to deal with it in the very highly unlikely event that one does occur. So have I totally blown your time budget now, Ms. Sabrina, or am I?
Not in the
close?
least.
Okay.
John, thank you very much. I learn something every time I hear you speak. So thank you very much for sharing that those slides with us. And John, you know, you have agreed to
Yes.
stay on through the end.
Yes,
if
ma'am. I
anybody
will be
else-
here. I will be here for questions as long as anybody has questions.
Okay, wonderful. Thank you very much. And now, as John just so eloquently referred to, with the emergency response plan, I want to bring Kylie back in now to discuss our emergency response plans and then a couple other slides as well. So Kylie, I will let you take it away.
Yeah, so as John mentioned, a lesson learned from Satarsha was their outreach program and the lack of knowledge in the surrounding communities for what to do in case of a large scale unlikely rupture. And we've taken that. PHMSA has come out with detailed information on the concerns based on what happened in Satarsha. And we have a person dedicated full-time to going around and discussing with emergency managers across the entire footprint of the project, their concerns and their needs at this point. And then we have a team beyond that who's creating emergency response plans that before we ever go into operations, will be trained at all levels of emergency responders in each county of our project footprint before, you know, one bit of CO2 ever goes into the pipeline. At those points, we'll have trainings, we'll have conversations on needs, but what it really comes down to is the emergency responders at the local level, their ultimate goal is to establish a perimeter. They'll have the knowledge and the understanding based on the season, based on the location of how far a perimeter needs to be established to make sure no one enters into that area. And at that point, we have experts, trained emergency responders that come in from local areas to handle the more massive emergency response requirements, rather than it being dependent on, you know, oftentimes volunteer firemen and situations like that. So we'll have all of this training that takes place prior to us going to operations, and then we have yearly requirements of continuing that emergency response and the emergency response plans in each of the areas that we're operating. You know, we'll have over 100 operators that will live and work across the pipeline footprint, oftentimes to do things like answer an 811 call. So they're available and living in the area to do trainings and periodic updates, and then the required PHMSA regulated emergency response updates. So that's talking specifically about emergency responders and our goals and plans and requirements for that. But there's also the public awareness piece for the people who aren't emergency responders but live in communities that will be near the pipeline. And we have a full government affairs and outreach team that is working on various different options for the general public to be able to come in and learn and understand CO2 and the risks related to it. So that whole plan will roll out simultaneously with our emergency responders plan. We'll have various, continue to have, we've already had quite a few open houses and other training sessions, and we'll also begin to join state by state local emergency response teams that go and teach, you know, all the different things in one session. So you don't have to individually come just for CO2. So we'll begin to join and add all these as we get closer to construction and operation. But we have a robust emergency response plan for at all levels for the local responders, for our specific responders, as well as for the general community in the unlikely situation that we have to utilize that, you know, worst case emergency plan. Go to the next slide. So indemnification is a conversation that we have a lot when we're talking to the general public as well as the landowners that will be a part of our pipeline. There has been some confusion that there's an expectation that you need to insure the pipeline. So indemnification insurance are a little bit different. In every easement that is signed across the project, we have an indemnification clause. And this means regardless of the activity, with the exception of intentional damage done to the pipeline, there is liability, and it indemnifies all person and all injuries from any incident that may occur, even if, if they at their result. With the exception of intentionally going in at the point to do harm, you are indemnified. All standard agricultural practices, all standard work that you do day to day on your farm or your property, all cannot be considered intentional malicious intent. So we indemnify every landowner, and it's written into every easement that's signed across the project. And then on the insurance side, we insure the pipeline. There is no expectation. You don't even have the capability to insure the pipeline because it is insured by Summit Carbon Solutions. So when you hear, we call our local insurance and they can't insure pipelines, that's because we, as a pipeline company, insure pipelines, and there's no obligation on the landowner to hold that insurance. That's about all I had, I think.
I think so. Thank you very much, Kylie. Okay, we've gotten a couple of questions, and so I'll just start reading through these. And Kylie, if you want to stay unmuted, because I think you'll be the first up to answer this. Why don't we use a railroad system that's already in place? Why disrupt farming practices?
Yeah, so the railroad system that exists today doesn't have the ability or capability to handle 10 million tons per year of CO2. So that's the first. There would have to be a large build out of both infrastructure and trains themselves to even be able to handle that mass amount of increase in production when our rail system already has a large amount of transportation requirements as it stands today. And then beyond that, and maybe more important than that, the safety aspect of transporting by rail versus transporting by pipe. The rail are subjected to everything that happens above ground, and infrastructure and the weather and human error of transportation. Where when you're getting to a pipeline, it runs underground below, the activities of the day to day. And it's been proven that I think the stat is 99.999% of everything put into a pipeline gets to the location it was going to. And the stats when you're talking about train and truck, they just don't have anywhere near comparable safety metrics that the pipeline system does.
Next question.
Can I add one to that, Sabrina?
Yes, please. Of course, John.
And I'm glad Kylie mentioned it. Pipelines are the safest mode of transportation in the US. But also there's the issue of volume. Pipelines can operate at high pressures, and CO2 in the dense phase that Summit will be transporting is about 10 times more volume than in the vapor phase. And it's just impractical to build rail cars that can transport a super dense liquid phase CO2 at very high pressure. To my knowledge, that just doesn't exist.
How do you show proof that you have reduced the carbon intensity score through carbon capture and sequestration?
So this is a pretty robust measurement that's been created by the government, and exactly how to do it. So we will have flow measurements that at the capture facility that tells us how much CO2 did we take from that specific ethanol plant. And we will true it up at the sequestration location and say, yes, every bit of the CO2 that went out at the ethanol plant is going permanently underground. And they will use those specific statistics of how much they were able to capture in any given time period and use it in the calculation that will ultimately determine their carbon intensity score.
And I'll just add on to there as well. There will be sensors at the sequestration site to ensure that the carbon dioxide doesn't leak back out. And if it does, then any benefit that we receive from that lowering of the carbon intensity score, we will have to give back. We will have to pay back because it has to be permanent sequestration of this carbon dioxide. Okay.
Yes, I was just going to add, there's a lot that goes into it. It's actually pretty complicated, including, the CO2 that we use during construction. All has to be factored into determining the carbon intensity score for each individual plant.
A couple questions all revolving around odor and a marker odor added to the carbon dioxide to help detect the leak. Will that be added? And if not, how can people be aware that a leak has occurred?
There will be no odor added to the pipeline. In terms of awareness, it will be part of the emergency response plan that will include a text message or phone call, depending on the setup program, to the surrounding areas. Sorry, now I'm reading the question and trying to answer it at the same time. But we have a facility that will reside in Ames, Iowa, that will be able to immediately detect any loss in pressure or temperature in our pipeline. So we will immediately be aware of a release of small to large scale and allow us to control the system. We can remotely at that point close down our valve systems to lock in any concerned area. And we have the ability through our emergency response plan to notify all in the area and the local communities.
We have a comment, and I think I'm just going to rephrase it into a question. Is there any plan to work with local emergency responders in coordination to create these emergency response plans?
Absolutely. They'll work individually with each county to determine those plans.
The final question that we have right now, so if anybody has any other questions, please feel free to put those into the chat as we're working through this final question that we have. Okay, good. More questions are coming in. So this is not our final question. Sorry, Kylie. But since the CO2 you are removing is naturally occurring, coming out of the corn crop, how are you going to replace this necessary element in growing plants as you remove and lock it away? There is concern about decreasing of yield over time.
Yeah, so currently there's been just a constant increase in CO2 in the atmosphere, a measurable amount of increase. And by percent that we're taking, there is no risk to, the amount of CO2 that's needed to grow crops, at the rate that they're growing today, in comparison to additional infrastructure that is continuing to add more CO2 to the atmosphere.
How long does it take to close down the pipeline? I'm assuming it means if there ever were to be a leak, and how much CO2 will escape into the pipe until the pipeline is closed?
This is a hard answer. It's completely dependent on pipe size, on how fast the valves will close. It ranges, I think, from a minute to 2.5 minutes. From the point that we start to close the valve till it being fully closed, and the amount that's emitted into the atmosphere is going to range based on how far apart those valves are and the size of the pipeline in that specific area. So if whoever asked that question wants to reach out and have a more specific conversation, I'd be willing to do that.
There was just another question of how many miles is between valves, and I know again that's kind of a more complicated answer than.
So the max spacing for valves is 20 miles. So we took that 20 miles and we did various engineering studies, including determining high populated areas, major river crossings, and several other factors that we then brought the valve in from that 20 miles or added additional valves to the project. And it's state by state dependent, but I think on average, they're less than 15 miles apart across the footprint of the project.
Okay, I think that's it for questions. So thank you everyone for joining us today. John, Joel, Kylie, thank you very much for your time and answering all these questions. Does anyone have any final points they want to make before we hand it back over to JC? Okay, hearing none. JC, I'll hand it back to you. I'll stop sharing my screen.
Thanks, Sabrina, and thanks to everyone who joined us today. A big thank you to everyone at Carbon Solutions for your presentation. This webinar was recorded and we'll make it available on the ISAC website shortly. If you have questions for the Summit Carbon team, I did include most of their contact information in that initial email that was sent out. Contact information for preferred vendors can also always be found on our website at iowacounties.org. So thanks to everyone and have a great day.